Hi everyone, good morning, good afternoon, good evening, wherever you are. I'm your host, Dr. Haider Shah. On behalf of Calvas, I would like to welcome all of you to this webinar. Thank you very much for joining us. Today, we have another very interesting topic, and I'm really honored to welcome and introduce our distinguished guest speaker who is going to talk about next generation technologies in electronics and computer science trends and teaching approaches, particularly. As we stand at the edge of rapid technological transformation powered by AI, quantum computing, advanced electronics, and digital innovations, there is a critical need to align our teaching strategies with emerging industry needs. And today's this session will explore how new technologies are reshaping the future of electronics and computer science and how educators can adapt their methods to prepare students for tomorrow's digital world. Indeed, a very interesting topic, and I'm sure you will learn a lot from this session just because we have a guest with us in this session. So stay tuned because we have the amazing stuff are coming ahead in this session. So before we start, I would like to thank Kalwas for arranging such enlightenment session for their support and providing us such a wonderful platform. The aim of Kalwas is to give you the opportunity to connect and interact with world-renowned speakers, academic leaders, teachers, authors, researchers, experts, professionals, and businessmen to learn from their experiences, recommendations, and suggestions, which will create an impact and will enable you to learn and develop yourself in order to grow and transform individually, as well as to contribute to the world in a positive way. As our slogan is come, learn, and share knowledge. So today we have an amazing person as guest. He is internationally known and recognized speaker, a multi-dynamic person with a great qualities and having vast experience and exposure. He is a great human being and always ready to contribute to the world in a different positive way. So let me introduce him formally. He is the assistant professor and head of Department of Computer Science and Engineering in India. He is pursuing his postdoctorate research at the Multimedia University and Quantum Machine Learning. He is presently working, as I mentioned earlier, as assistant professor and head of Department of Computer Science and Engineering, Greater Kolkata College of Engineering and Management, West Bengal, India. He has more than 14 years of teaching experience and more than 9 years of research experience. He completed his BTech in 2007, MTech in 2012, and PhD in 2022. His research interests include the sensors, the nonlinear process control system, mathematical modeling, electronics system, the control optimization, algorithm, intelligence system, Internet of Things, machine learning, deep learning, quantum machine learning, etc. He has 14 international national patents and has published more than 120 research articles to his credit. Published in international and national journals and conferences proceeding as well. Along with that, he has 21 edited and authored books, 23 book chapters under reputed book publisher elsewhere and Springers. He has also received a grant from a national and international project funding. Along with that, he also serves as a reviewer for the IEEE Internet of Things Journal and IEEE Transactions on Intelligent Transportation System. Last but not the least, he's a wonderful speaker, author, teacher, researcher, professional, and above everything, a great human being. So please help me in welcoming our guest, Dr. Pijush Dutta. Welcome to the Calvas platform, and thank you very much for joining us, Doctor.
Thank you. Professor Shah, to give the opportunity to share some information regarding the next generation electronics and computer science. Actually, this one is a very emerging area in a modern era because as the day by day is promoting the new technology, because actually whatever the I going to present to the audience, what about the actually present scenario and what kind of actually tools and techniques are actually implemented last decade. But now after the incorporate some new technologies that industry 5.0 or industry 6.0, what will happen, some technology are incorporated, and earlier some drawbacks are found, so how it can be recovered in a new technology, new domain. And as a we are actually the researcher and the teacher and the faculty members, so we have the responsibility to carry ahead the students to express their work, the students' work in a new dimension. So that is actually main topic, and it is my pleasure to give this opportunity to share some information regarding this. Thank you.
Thank you so much. Thank you so much for your valuable time and looking forward for your wonderful session. So over to you. Thank you very much.
Yeah, thank you, sir. I hope it is visible, my screen.
Yes, it's visible. Carry on,
Okay,
please.
okay.
Thank
Thank you.
you.
Yeah. So, very interesting topic. I am going to express next generation technologies in electronics and computer science. Actually, in a modern era, that is we cannot say a particular domain is very is feasible, because in a new technology, after incorporate the new technology industry 4.0 or 5.0, you have we researcher, you always try to mixed up some others domain, that is interdisciplinary research. So I appreciate that you choose this topic for me to give the expression, because electronics and computer science is a very attached domain, and one of the thing that is everyone knows that, because artificial, after incorporating or including the artificial intelligence is widely used in every area. So that's why it is a very hot topic for the students, as well as the researcher and the faculty members all around the world. My name is Dr. Pijush Dutta, head of the department Computer Science and Engineering, Greater Kolkata College of Engineering and Management, India. So without just waste of time, I just go to the actually what is actually main thing is going on. In present scenario, what will happen in this in presentation, what will happen in a modern era, what are the actually present trend, and what are the actually main technologies are incorporated, and as a we faculty member and talk to the students. But after a propagation of the industry 5.0, 6.0, so what will happen, we implement some new technology, so that some drawbacks which are found in the earlier, that can be overcome. So first one is actually evolving of the knowledge. So if we go to the actually visualization, it's seen that that is the first is a fundamental. So what is actually the principle and theory, and after principle of the theory, and in present scenario, we get some current application technology. What are the state of art technology? Suppose if we go for the any as an electronic student, every students, you know that the VI characteristic of the diode, or the VI or the voltage characteristic of the transistor, as a part of the at the initial stage of the transistor. So in modern era, what will happen, how this voltage current characteristics can be improvised by applying the artificial intelligence. But now what will happen, artificial intelligence is not in standstill condition, because after the quantum computing or the others methodology are already incorporated. So how we can get the betterment of the result, not only betterment of the result, we can also consider the how less space is required, because as a software engineer, or the as a we are using the simulator software, so it is one of the thing is how much less time is required. Okay, and that the computational time and memory space. So these are the actually different parameter we have to taken care of, because in earlier, if we use a particular software, and if we want to predict some output, so it is a very time consuming, or it may be also observed that the space is required very high. So as a technologies, as a researcher, we always try to reduce this kind of parameters or the limitation. So the present scenario means that is what is the actually present trend is going on. What are the researcher or the faculty members or the students, they are actually right now, what are actually we're doing now, and what are the actually future perspective, and how we incorporate some pedagogy, that is how we as a faculty member, the researcher, how we encourage the student to use some technology, to use some methodology, so that we can achieve those results. Because what will happen if we give an example, like an if we are going to implement a process control modeling. So generally what will happen, it is a one kind of black box model, artificial intelligence. So here there's some variables having some relation between the input variables and the output. So it is very difficult to identify for a given set of input, it gives a perfect output. It is very difficult because the number of data set is very less. So if we want, suppose x1, x2, x3, and x4 are the 4 input variables, and y is one of the output variables. So if we want to finding out for a given instant of the input, what will be the output? So what will happen as a researcher or the other student? We have to repeatedly we performing the experimental work until or unless for a given set of input we get the output. So that is actually main thing, and that can be overcome by the artificial intelligence. So artificial intelligence now it's fine. Okay, now the artificial intelligence now categorized in a different part, that is a set, subset, super subset, like that. That's a machine learning is a part of the artificial intelligence. Now machine learning, under the machine learning, it is again entering into the super subset as a deep learning. Now it is entering into the quantum machine learning. So each and every sector having some advantage and some limitation. So as the technologies, as a researcher, we always focused on how this limitation can be overcome by the next technology, how to incorporate this technology. So as my domain is artificial intelligence, so obviously because my actually background, my graduation is under the electronics, my master's in mechatronics, and my PhD in artificial intelligence, and now postdoc is going on quantum machine learning. So I can say that now the world is not is like in a particular way. If we go forward, so you have to learn all the things, and how, and you have to imagine that how it can be incorporated the multiple or multidisciplinary work in a single, as a single person or a single user. So you have to learn all the things, and the main thing is you have to, if you have this, I mean, if you have a strong knowledge, or if you have a knowledge about the mathematics and the physics, so it is obviously all the things in your hand. So as a researcher, we can say that is most of the students or the faculty member or researcher, we use the ChatGPT. But the one thing we are also remember that ChatGPT is only possible and gives the exact result if we give this perfect prompt. Without perfect prompt, it cannot recognize what we actually want to do. Because if a same question is arise in mind, and at the same question is arise to Professor Shah, because if we have the different comments, the same question, we have get the different result, and it is a one kind of actually matrix. Actually, it is a one kind of agentic AI, and it gives a matrix, and this matrix is actually one kind of fittest matrix. That is what we want and what it gives according to that question, and that result is differed how I give the instruction to the chat GPT. So that is such a one of the important, because it is a modern era, and we learn all the things as a researcher, as a students, as a technologist, we have to learn this. So this is actually first part is evolving the knowledge. So that's I highlight, that's how we go from theory to teaching. That is, at first we have to learn, I already told you that we first learn the what type of knowledge. That is, just few minutes I get told that is a chat GPT. It is nothing but it is one kind of it is the one kind of intelligence system which gives the fittest output question to the what kind of prompt or what kind of information given. So it is nothing but is one kind of matrix. So if a students or the researcher or a technology is having this fundamental knowledge, so he or she can achieve the desired result what he wants to. So that is actually, that is called pedagogy. And as a researcher, as a faculty member, we need something. That's why the pedagogy is one of the important thing. There's a teaching methodologies, curriculum development, learning strategies. Curriculum development is one of the part, because most of the university and institution, we need to focus that how the curriculum can be implemented in such a way so that we can help the student how to solve the question. Because in most of the cases, what will happen, we give some question to the students to get some knowledge, theoretical knowledge, and during the class hour, what will happen, we ask them, whatever you got the information as a theory, just go to your lab and try to implement as a lab, in a practically we will show this thing. Like that, it is it is Ohm's law. It is a V proportional to I. Okay, fine. But can you implement this model by AI and put some data? If the current is this one, then what is the value of the voltage? Or if we give the some value of the voltage, then what is the current? Can you show this? So you acquire this information in theory and you implement it as a practically, because it is as a human being, it is very easy to capture the theory. If we implement this thing by practically, then it is very understandable for the student as well as the researcher. So that is actually main focus for the as a faculty and the researcher and the technologies, to encourage the student how we can process this. So that is actually first point that is I want to highlight, is the evolving the knowledge from theory to teaching. And most of the cases I also encourage the student, like in my institution also, the how to prepare, because what will happen, it is very time consuming. Like if I some images, suppose in a project writing or the report writing, when we give some project to the students, so students are very confused. Then what will happen, they just go to the Google image and copy it and paste into the text. So what will happen, at first I have to ask them that this is not the right way, because you just stealing someone information. Try to implement this in yourself. So that's why you have to, there is a lots of AI tool. There are lots of AI tool. You have to try to give some the correct prompt, so that it can help to generate the, because correct prompt is another technology. That is, you have to some technology part. So if you give the correct technology word, so it automatically generate the image. So that is the actual, because you have to implement some knowledge. Because copy and paste is a nothing, is it is a stealing someone information without giving any credit. Next, I want to highlight that is why this actually the seminar is going on. Actually, we are actually mainly focused. Whatever do we go into the any domain, that is in we go to the electrical engineering domain, we go to the mechanical engineering domain, we go for the civil engineering domain. Whatever do we go into the domain, AI is one of the platform which can help the any researcher, any domain can implement or mathematically formulate the any system. But in this research, as my topic is actually in domain of the electronic system as well as the computer science, so how this electronics and the computer science can be motivated by the AI native. Then heterogeneous and domain specific, that is how the computer, in earlier there are different kind of computer or architecture is given there, von Neumann, super Harvard architecture. But in new technology, so you have to focus that the AI is fine, okay, fine, but is this processor is suitable to execute the instruction, or what kind of model you going to implement? So is this system is suitable? So that is the main thing. If I going to implement a mathematical model of a solar cell to predict the how much radiation current is generated for a given temperature, or the saturation current, or the biasing voltage, or the Boltzmann constant, or everything is parameters given for my system which is operating in a suppose i5 processor, and some of the researcher who actually working in i7 researcher, so obviously some of the reflection of the result will always differ. So the architecture is one of the important part for the modern research. So whenever the student or the researcher or the technologies, we are going to write any kind of or prepare any kind of technological report, so they always highlight those things. Next one is the education needs the deployment of fast thinking. That is, you have the first is you have to focus on how to think about this, because without thinking power you cannot create anything for by yourself. Otherwise you are just what will happen, you just copying the others information. Because when you go into the upper level, if you go to the in a multinational company, or you are going to the higher study, for you have always the first part is how you think of a particular topic. Without the thinking capability, it is not possible to implement anything. So education help us to create to think about how we improvise the thinking capability. Next is the electronics and complex emerging convergence, because the convergence is one of the important thing, because the topic is actually how they incorporate the electronics. Because I already mentioned that in a particular thing, that is electronics, it is not we only electronics, it is nowadays is very difficult to sustain. So you have to acquire the others technology, other technology, how to this technology can be incorporated to the electronics. So to accelerate this work, we need the computer science help, not only electronics, in every area. So that is actually convergence, that how this can be implemented. So first one is the hardware acceleration. how these hardware parameters can be implemented. The hardware means automatically entering into the electronics domain, and the algorithms to optimize the hardware component. So algorithm means obviously it's entering into the computer science. Optimization is again entering into the computer domain. And the network connect intelligence, that is how the swarm intelligence and the edge technology. So this kind of IoT, so all this connecting network can be incorporated by with the help of the electronics and computer science. So this point is mainly focuses how the computer science and electronics can be converged to accelerate the research for the next generation. This one is actually, I want to mention CDCISS. That is such a core pillar for the electronics and the computer science. What are they? That is a compute. Next is the device. Third one is the communication. Fourth one, the intelligence. Fifth one is security. And the sixth one is sustainability. Now, in UN nation, the sustainability is the mainly focus, because we cannot do the research work without aiming something. That is, without aim, we cannot do nothing. They're having some boundary, that is a sustainability. That is what type of research you are going to, and how it affects or can change the environment for the betterment. So sustainability is one of the important thing. That's why these are the actually core pillars for the computer science and the electronics. What is the compute? I already mentioned that the compute, without compute, we cannot actually compute is nothing, but it is all the things is related to data. If you have a data, then you have a capability to do something, and you can help. It can helps to characteristics the nature. It helps to visualize the nature, and it also helps to forecasting the model for the new set of data when it is given into. Next one is device. Obviously, if we go for the sensor, if we go for the actuator, so the device is the main thing, because without device you cannot get the data. Next, the communication, because if I go for the example as a IoT, so obviously IoT means it is seen that during the 2020, when the COVID is widely spread as a epidemically disease, so it is seen that in earlier the most of the we know that is the embedded system. So in embedded system, generally there is no facility of the internet, but when these devices are incorporated to the internet, so it is turned into the internet of things. Let an example. If I go for a patient who having the oxygen levels is does drawn down, so now what will happen? One of the family member of this patient is sitting beside this patient and observing what is the actually oxygen level of that person, and according to that, what will happen? What kind of precaution is required? He immediately communicate with the medicinist. Okay, now that is the main thing. So it is very it is a very quite impossible, because each and every 24/7 you have to give a person assigned to observe what is actually the level of the oxygen of that patient, and according to that you have to communicate with the or with the doctor. So it is very difficult. Now what will happen after the incorporate of the internet of things? What will happen? The sensor is fetching the data, real data from the patient, and it go to the there is a controller, and it's sent to the cloud, and that cloud is implemented by the hospital or the medical center. So according to that, if the any kind of oxygen level is just running, what will happen? The medical center immediately send to the oxygen cylinder oxygen to the patient party or the patient house. So it does not require to assign a particular person beside the patient as a watchdog timer like that. Okay, so that is actually incorporated of the IoT. So that is actually main thing. That's a communication. That is the term is emphasis. The how one of the device can send or exchange the data to the other devices. Next, intelligence. Obviously, we are actually human being are very intelligent, because we have the capability to understand the data, to understand the visualization. We can forecasting the data. So this thing can now done by the robot or the other devices like the agent. So intelligence is one of the part. Next one is the security. We know that is now what will happen. There is lots of cyber crime is going on. So if the data is not protected, so obviously any people can enter in your cloud and import some fake data, so that you can get the irregular nature of the characteristic of that model. So security is another thing. Now, last but not least, sustainability. I already mentioned UN nation already assigned SDG model for the researcher, so that we cannot do aimless research. Our aim is to do some research, do some work, so that it helps the societal advantagement, so that society can get the advantage for our research, for our whatever that we going to implement. So that's why it is I mentioned as CDCISS. So this model actually just incorporated how the computer science and electronics engineering can just link with this. So that is actually convergence. Next, I go to the actual legacy. So this actually just flowing. I just mentioned that how it go entering the industry 3.0. That is actually go to the automation part, like the in mechanical time part is like a PLC, programmable logic controller. This kind of device. Industry 4.0 is connected AI. That is the IoT related. Now, industry 5.0 human centric. That is actually the robotic. The in present scenario, how the robots can utilize in a different sector. So these are actually the future timeline. How it is go for the advantagement for the intelligence, advantagement for the time management, advantagement for the computational. So this perspective it is proceeding. So in the next one, obviously go for the industry 6.0, so on. It will go on according to the requirement for the society. This one is a fundamental of computation. That is the finally actually when we are going to the actually what will happen in analogous nature data can be we used, because as we most of the students we are actually electronics domain or the computer science domain. We know that it's an analogous signal and digital signal. But what will happen? The main thing is in analogous signal it is very adhesive with the signal to that is very noise adhesive to the noise, because in environmental noise can affect the wave shape of the signal. So that is actually main drawback. So that's why as a researcher, as a students, we always mainly focused on the digital signal, because it having the having some maximum immunity how to protect the noise. Okay, so that's why we always mainly focus on the binary or the digitized data. So that is a fundamental of computation. That is, if we go for the lower to higher, that is a binary. Then binary means that's a 1-0 binary stick. Then according to the, we'll go for the logic gates. Next, we'll go for the instruction set of the architecture. Next, pipelining is one of the important parameter. By applying the pipelining parameter, what will happen is the pipelining is nothing but it is a process which can help us to execute the instruction without staying in a particular waiting state. Okay, in earlier what will happen, if given instruction, it giving instruction that it go for the execution mode by the computer. But nowadays what will happen, if there is a pipelining concept, so one at a time we give a multiple number of instruction in a queue. So it help us to without waiting any instruction, it is one by one it is executing by the processing unit, that is central processing unit. So it makes the processor more faster. So it needs some basic knowledge of the students, that why I mentioned that is a higher processing unit or the higher performing processor. Why? Because these are the actually main part is the pipelining, because most of the high speed communication system having this pipelining concept, because this pipelining concept will help us to execute the instruction and it does not give the any waiting state. It gives the instruction, fetch the instruction from the program counter from the memory, and it automatically go send immediately and is sent to the execution unit to execute the instruction. So it helps us that to execute the instruction very fastly. And next to the memory hierarchy, that is how the less number of memory. That is, if I have the 8K cross 8 memory, 5 RAM, we having the memory space is 8 cross 8, and how can this 8 cross 8 memory can be incorporated to make to get the higher memory storage of the memory. So this kind of hardware topology also we need as a student, as a researcher, as a faculty member also. Next is this one is actually I already mentioned, that is there's a von Neumann architecture, that is a parallel and distributed need. Parallel means that is von Neumann is actually serial communication. Serial means is like that. If I say that is in a racing competition, if there are 100 number of students there, and I ask them that please one by one just run, and I just counting the time stopwatch, that which students getting the actual less time to complete the 100 meters. So it is a very less, it is a very time consuming. So that is actually serial communication process. But in a parallel, in a modern technology, what will happen if there are 20 tracks and 20 students are asking to just standing in a queue and just run in 100 meters. So what will happen in a single of time, the 20 data is transferred from one device to another device. So it makes the system more faster. So that is one of the things. So that is actually parallel and distributed need to bottleneck the work. That's why the von Neumann is actually very limited for the modern research objective. So obviously the hardware software co-design, is nothing but that is when we going to as a student, when we going to implement the any prototype. So at first we have to identify that this project is really feasible to implement by hardware model or the software model. Like an example, cyclic redundancy check is one of the very important topic in information theory and coding. So some of the students always identify that is the thinking is one of the thing, one of the parameter to design any prototype or any research work. So he or she have to justify that if I implement this cyclic redundancy check by using the hardware, so what are the limitation and what are the actually advantages? And if the cyclic redundancy check, this module implemented by the software by using the MATLAB or the other implemented software, so what kind of advantage or limitation we can get or achieve? So make a comparison and go that way, which giving the maximum facility or maximum advantage. Because in a question will be coming out, why you go for the hardware implementation? Why you don't go for the software implementation? So you have to asking this question if you go for the both the topic, hardware as well as software, because you are already survey all these things. Next is the computing model, is one of the thing, because there are lots of software we can design this model. Because before going to the any hardware circuit, we always go for the simulation software to give, because simulation software is there is no chances for the breakdown of the system, because it is our choice and how we give the some inputs and how to connect with all the rest of the modules to get achieve the result. So computing model is one. Next is a survey the current platform and their limits, because in earlier there are lots of researchers going on or lots of experiment is going on. So what kind of actually the link or the some information, some potential information we achieve after surveying all the related relations information, and according to that we go for the machine learning algorithm or all the artificial intelligence like that. Explore the next generation trend, that is actually main thing, because already the previous what kind of research work already done in the last couple of years. So and what are the scope, how I implement, because in a generally what will happen, research is not like that I just innovative the 100% of the novel idea. It is not like that. You can implement the new methodology, new technique, system is okay, or you can implement the system but model is already innovated by the some researcher, you can implement this. So to explore some new technique or new methodology or new concept, that not means that is 100% of the year, because you are actually going to the as a scientist. So emerging platform, because as a student, as a faculty member, we need to learn some emerging platform. Next, get the concrete teaching approaches because I already mentioned that as a faculty, as a teaching, as a teacher, as a researcher, we always assign some theoretical, ask the student to get some information, to read this kind of article and acquire some information. After getting some theoretical concept, to go to the lab and implement in an experimental way. So justify that yes, what information you got after reading this theoretical, it is justified to the practical or not. So that is actually main thing, and go for the other project also. fundamental idea, computation model. So algorithm, then compiler, these are the actually main architecture which are actually incorporated in it. There is a von Neumann architecture, I already mentioned, that's real. So these are the actually instruction set architecture. This is actually main part where the electronics and the computer science, how are it is incorporated. That's the how it is algorithm go to the for the execution, that is a compiling, that is any kind of coding or error is a finding or not. Then instruction set architecture is it is helps to what in which section or which module need to be modified. Then it go for the micro architecture, and then it is go for the actually silicon structure or like that. So this is actually software to hardware implementation. That before that we go for the actually software implementation, then you go for the hardware implementation part for as a abstraction of the electronics component or electronics chip. So these are actually main views actually shown here. That is the multiple number of the intercepts of the computing knowledge is incorporated to implement the hardware, because it gives the betterment of the IC configuration or the better output of the IC manufacturing companies to get the to incorporate the algorithms to finding out the better output or better result. Next, the hardware software co-design is already I mentioned, but in modern times, what will happen? In most of the cases, we always mention that it is not possible that all the data will be like a digit. It is not possible. Some of the cases, what will happen? There are some images also. So if it is an image, then the machine learning is not feasible like that in that stage. So at that time, we need actually deep learning model. So here the traditional model is actually convolutional neural network model. So for the visualization and according to the deep structure of the convolutional neural network, we can again upgraded the convolutional neural network model by incorporating some deep structure like the ResNet model, like Inception, like VGG. There are different CNN model, and there are a huge scope. How? Because what will happen in some of the cases, visualization is one of the important part, that if this IC is actually really damaged or not. So in that case, what will happen? There are 200 number of samples of the images of the IC, and these 200 number of images are trained by the CNN model, because the CNN model helps to classify the images data. Now in the next step, what will happen? Suppose is IC having some damage, that some snaps are there, and if my company is asking me, or my guide is asking me, can you justify that this IC is actually the damage or not? So that time, what will happen? I just train this model that yes, this IC is actually the damaged or not. So that is actually main thing. So the some of the cases, what will happen? The visualization is one of the important parameter in artificial intelligence. So it can helps to identify which one is actually falls under which category. So CNN is such a fundamental deep learning model which can help this part. Next is actually like that. Show a simple example CNN, then it quantized and mapped to the FPGA. There's a field programmable gate array which identify that is a CNN is actually the software part, and it go for the map to the FPGA. It is a hardware module. So it helps to trade off between the all the hardware and software module. So it helps to reduce the latency. It reduce the computational time, execution time. So this kind of things can be overcome by this concept. Next, the fundamental idea for system thinking. What are these? These are actually distributed system, first one, because maybe some of the components not actually incorporated in a single chip. These are actually separated in a different box. So how you linked all these things? How the edge and cloud continuum can be incorporated? That is how one device to another device can send the data, and what are the real-time constant, because whenever we're going to study any research work or the research article, certainly there are some limitation. So we have to focus on this, that what are the actual limitation, and is there any scope to overcome this constraint. So when we go for the any work, so we have to also observe that what are the actual real constraint to implement this model. Next, is a security, obviously the privacy, reliability as a first class concern. That is, whatever as the system is implemented by the student or the researcher or the faculty members. So the main thing is it is the reliability, because it's not like that if any one of the environmental parameter is changed and the whole system is working in a different nature. So that system should be reliable for in every sector. And the security and privacy, the one of the thing that is main thing, because it not think that I just operate a robocop, and what will happen, and sometimes the another person, what will happen, this that person is actually remote control my device. So it is not like that. So that should be privacy, that this thing should be controlled by the a single user. And the security is another concern, because whenever we're going to design any hardware devices, the security hardware or software devices, security is another important perspective for the system thinking. Next, the present trend, because I already mentioned that is a deep learning, transformer learning. These are actually different. These are actually different model and how this can be utilized. Because what will happen? There are lots of actually online application software is available, because we already know that is a Google Colab. It is a very flexible to use by the researcher or the students, or anyone can use this. So they can use the machine learning, deep learning, or any kind of cloud computing application. All this can be even with the quantum machine learning, that can be applied by the can be executed in a Google Colab by incorporating some by incorporating some library. Next, the present platform and software. These are the actually platform that is which can be used in a modern trend by the domain who are actually in electronics or the computer science domain. So machine learning framework, embedded system, I already mentioned, because after the in an embedded system, it is now upgraded into the IoT, Internet of Things, where the internet is a mode of is the main thing which gives help us to analyze the data of a system. Next is the hardware design. Next is a Raspberry Pi and FPGA platform, that is field programmable array. Then cloud platform is AWS and quantum. So this quantum computing, there's Qiskit, Sark, and Pennylen. Most probably along all this, Pennylen is a very easy for me, because I also work on this. So Pennylen is one of the, I think Pennylen is a very feasible to work on it. And next to the robotics. So these are the actually pleasant scenario where any electronics or computer science students or the researcher are working on any one of this platform. Next is the present for limitation. What are the limitation? Each and every having the some limitation. And what are they? As a technologist, as a researcher, what are these? We have to focus on this. What are the limitation in the previous system, and how we can overcome this limitation. There's a TensorFlow, which are actually we use in a Google Colab or Python. So these are actually heavy, and what will happen in some of the cases, it takes a longer time. So latency issue is most of the thing. This is the exploratory data analysis, express a steep learning curve. That is, it takes actually from upper to in a what will happen. There's a converging. That is a converging rate is very slow. And a long iteration cycle. That is, it takes supposed to get a stable output. It takes 1,000 or 2,000 number of cycles. So this is actually main problem. Next, FPGA field programmable array. So hardware expertise. That is, if you are expertise on the field programmable array or the system on chip, so you can go for the further researches. So for a fresh learner, it is very difficult. So you have to give 3 and 4 times training, or the you have to involve yourself for a 1 year or 2 year to get the actual betterment of the knowledge. After that, you can go for the research worker. So that is actually main thing. Next is the cloud solution, is the latency, the cost, privacy. Next is the quantum, the software development kit is a noise hardware, because in most of the cases we in a research work we always mention that is how much the noise is incorporated in my system. So noise is one of the important thing. And the next one is the immature algorithm. Sometimes what will happen, it gives a betterment result in the next execution or the next iteration. It gives a higher maximum of results. So in most of the cases, what will happen, we have to take the average value. So this is actually main thing, that is the immature algorithm can be performed in a quantum software development key. So next generation. Now we go for the next generation because this is actually main thing we are go for the next 10 or 20 years. That is in quantum computing. We use quantum approximation algorithm, variational quantum algorithm, quantum machine learning. So these are actually the upcoming research work is going on because this thing can be implemented in a drug discovery for the medical application, each and everything. Even this kind of thing can be incorporated with the other technology, other technology, because these are right now the hybrid technology is actually going on, because this thing can be incorporated with the blockchain or the cyber security or the cyber physical system. So the how this quantum computing can incorporate with the cyber security system or the cyber physical system or the blockchain, this kind of thing can be actually the coming research are going on. Already it is already started. Now the neuromorphic computing, that is a spiking neural network, that is SNN. So this kind of that's the upgraded of the convolutional neural network, the spiking neural network. So this kind of thing which are actually giving the very focused output, less computational time, less convergence rate. So this thing can be incorporated in a modern technology. Next is the photonic and optical computing. This is a term which is actually very related with the electronics as well as the incorporated the computer science, because it is a large bandwidth. In a large bandwidth and low energy task, a large high bandwidth, because what will happen in a most of the cases there is a bandwidth is a limitation part for the most of the communication system. So here it give the narrow beam, because we know that is if it is a torch, so the light is actually widely spread, but in which particular area I just focused on, it is vague. But if I apply the laser, then what will happen, in which direction I want to fall on it, and it is actually it is focused on that point. So it is actually what will happen, that is called the narrow beam. So photonic is a concept which can be implemented in a optical fiber communication or the optical computing, so that it gives a narrow beam and high bandwidth, as well as the signal to noise is the maximum. Because in a modern research we always try to reduce the noise, because signal to noise issue is the one of the important parameter who are actually doing the research or the studying in a communication engineering. Because the most of the thing, because in a communication system there are three important part. One is a transmitter, is a medium, and third one is the receiver. Now what is the performance of the transmitter is reciprocal in a receiver section, and the medium is the thing which always try to impose some noise. So as a researcher, they having some knowledge, so that the transmitter and receiver are incorporated or the design in such a manner so that this noise can be reduced in a maximum. Although the noise and the distortion is a very interrelated part of the communication system, you cannot remove all these things as 100% accurately. But as a researcher, we have the we have an objective to how to minimize these things. Next, the heterogeneous integration, that is how the silicon photonics chip can be implemented after incorporating the other software in a IC fabrication process. So these are the actually next part. Next is the next generation software and methodology. The hardware aware machine learning co-design, that is how the quantization and how the pruning is actually what will happen. Pruning in a most earlier, what will happen, suppose what will happen, pruning technique is actually a technique which help us how to cope up the unwanted branch. Cope up means that is we cannot go to the particular path which cannot gives actually our desired result. That is actually the pruning. So what will happen, the machine learning in a modern technology, what will happen, it helps us to prune the unwanted path, so that we can go to the exact path which gives the exact result of the maximum accuracy with taking the less amount of time. So that is actually the pruning is actually main part of the hardware aware machine learning algorithm, which is actually next trend or the next part of the research. Next is the on-device continual learning, federated learning, privacy preserving learning. These are actually modern trend, because in a federated learning or privacy preserving learning, these are actually very focused research in a medical healthcare system. And next one is the multi-level intermediate representation, compiler, stack. These are actually main focus now. In already it is started, and as well as it having the huge scope for execute for implementing the model for the future research work as well as. Next, AI assisted design automation, because most of the cases what will happen, circuit synthesis, that is how this circuit can provides the output with giving certain instant of the input, and that can be helped by using the artificial intelligence. So the artificial intelligence can help us for circuit synthesis, that how for giving for a given set of input, how it can react, and according to that we go for the designing purpose, that is for designing the hardware component, as well as also it helps to verification of this component. Next generation platform and software, it is already same, but we have to implement a more technology so that we get the more accurate result. I already mentioned like that in a previous slide, that is the quantization and pruning is one of the time. In earlier time what will happen, the pruning is not actually incorporated, but in now our main aims to we have to prune this, because we cannot wastage our time for applying in a particular algorithm for implementing a model, because if this model already give the is giving the less accuracy, or the convergence is very poor, so we don't want to go for this. So that can be applicable for the next generation platform. So all these things are implemented, but we have to just focus on this. These are actually, I want to say that these are the actually main thing we are focusing on for the next research or the next generation, for how this can be implemented, or how we can design this thing. So edge and tool chain improving, digital twine and simulation platform. So this platform can be implemented by us, and we are always already, as a researcher, we are already working on this. Look at this. This one is a Pelinen. This one is right now in a hybrid mode. So this thing is actually working on for the betterment of the result, or betterment performance of the model. Next is the principle, that is the project-based hands-on, that is I already mentioned. Interdisciplinary, that is how we encourage the students. Project-based and hands-on, that is a tiny type of project is given to the students, and they generate the idea, and according to that they can implement this model and deploy it. Yes, this is actually working on a real scenario or not. Next is interdisciplinary team. This is a very important thing. Make a team where the interdisciplinary students, like a computer science, electronics, or electrical, because each and every student, every department should require at least 20 to 30% of knowledge, because without that we cannot sustain. No students can sustain, because the technology is evolving each and every day. So we always focus on the interdisciplinary research. So to make this, the interdisciplinary team is always required. Next is a tool chain literacy. We also always encourage the students that how the tool and which tool they have to use, or we can ask the students that yes, you can just asking how we use a certain tool which can we can remove certain content of an article. They can use the quillboard, paraphrasing, all kind of tools. They can ask them that yes, you can copy any text and make some paraphrasing of this content, or use some synonyms so that it looks a new form. So some tool chain literacies, because now the generative AI is actually widely spread in each and every aspect, in every area. So let them open-minded that yes, you can use this, but give some output regarding that can help us to explore their knowledge, explore their thinking. Next, integrate each and every module to get the better output from the students. This one is actually main motive of our research. Next, the teaching approaches. These are actually digital logic circuit, hardware acceleration. Who are actually in electronics domain? They are always hardware implementation. Along with that, they also faculty members also encourage the students to implement the software, because after software implementation they go for the hardware circuit. Without software they cannot actually implement a hardware, because they having what will happen, they having some thinking. All the students having, every person having some thinking power. So let them think that if I increase this input, what will the output. Let them simulate this system, and after that ask them to design in hardware. So that is the main thing of the EC. And in a computer science, all the things are actually related to the software, machine learning, artificial intelligence, deep learning, etc., etc. Now, the main thing, each and module has a short lab and mini project. We have to focus on this. Whatever we giving some information, I give just them to prepare a model regarding each and every aspect. Project idea, that is a tiny FPGA, cloud and edge federated learning, quantum demonstrator, that is quantum machine learning. Ask them to quiz kit or the penny lane to run the different optimization algorithm in a tiny ML. That is the students can do some research on a microcontroller. FPGA architecture, they can also implement the hardware module, cloud and edge computing. They can use some measure latency in energy or the power transmission, federated learning, which can help to identify or build a model for the healthcare system. All this can be performed by simulated software. Assessment, and after that we have to assess the which student giving the better result, and because each and every student having the unique idea, and let them think about this. And after that we have to make a continuous assessment that what kind of output. It is not for the student, we also applying each and everything, because for paraphrasing we also use the quill board, and there are definitely humanized AI. They are different platform, and we have to survey this, that which platform gives a better result, because this thing are help us to think about the data, how we get the most betterment result. So this thing is not for the bounded for the students, but also researchers. Resources and learning, these are actually very available. Google Colab, GitHub, QuizKit. In hardware, there is Raspberry Pi. Arduino is a very flexible. Next, Coursera, and different type of platform where we can also read the contents and courses to get some information for this. Ethics and the practical barrier, that is these are actually very challenging things. You have to whatever we design or thinking about this, the main focus is a sustainability. This is actually main focusing, because this is the actually main achievement, that is, yes, I am doing this research and this satisfy the sustainability goal of the UN nation. So that is actually main thing. So whatever we thinking about this, or prepared any model, so that should be satisfied in sustainability concern. These are the actually next generation research scope, where the students and the researcher can do some work, which are actually still opening, that is a AI native and efficient computing, decentralized and cooperative intelligence. They have, these are the actually broad area, but if we apply this thing for the medical healthcare, or for preparing the mathematical model, or machining, designing the machining, all this thing can be implemented. Okay, even this thing can be implemented for the electrical also, like the high voltage DC system, like that. Okay, so each and every thing can be applied in a different perspective. Next, electronics and engineering, next generation. These are actually electronics and communication engineering, where the chip design, how the edge intelligence can be helped to hardware platform, the cyber physical system, real-time system, hardware and human-centered 5.0 system. These are actually very hot topic for the human-centered 5.0. The very hot topic, and right now it is widely working. Most some renowned researchers are working on this, how this human and artificial intelligence can be incorporated for modeling the industry 5.0 system. So these are the actually industry 3.0 to 5.0 overview. So in a core focus, what are the actually electronics domain, what are the computer science domain, what are the limitations. This one is actually industry 5.0. In the middle, this is the industry 4.0. What are the actually sensor? They need to go to the data, then cloud. These are actually nothing but it's a one kind of system which is very related to the actually Internet of Things. And next is a industry 5.0, where the intelligence plus human and the sustainable era. That is the actually main thing which are actually incorporated to achieve the industry 5.0. That is the main view. These are actually 17 UN sustainable goal is actually given. So whenever we're going to do any research, we have to focus on this, that my research is justified. Any one or two or three or multiple number of sustainable goal must be satisfied. These are actually mapping. If I go for the computer science and electronics, look at this. These are actually low power electronics and energy, sustainable SDG 7. So these are actually clean energy and affordable energy. If it is energy related, so it can help like that to design a low power electronics, because in a modern research electronics design, electronic circuit is designed which have been operated in a low power, because the power is one of the important parameter when you're going to for designing any electronic circuit. SDG7, that is industry innovation and infrastructure, that is the III, that is actually AI enabled hardware configuration, 6G smart infrared. These are the actual domain, and these are the application scope, because we not only sustainable goal, but how it can applied in those area. So these are the actually sustainable goal 7, 9, 11, 12, 13, which 13 and next is yes, that is a 14, 15, 3, 8, 10. These are the actually sustainable development goal, which are very linked with the computer science and electronics, most of the research work. So whenever any student or researcher or we going to any work, so we need to focus on this, because these are the actually very important thing to do the any prototype or research work. It should be remind us to get done. So thank you. So give me opportunity uh, to give my lecture on this topic.
Yeah, thank you very much, Dr. Pijush. Wonderful, very nice. I really enjoyed this session, and I could see that you did it very nicely within a proper time. I believe that you are a wonderful time management person. You followed the time in a very wonderful way. I really enjoyed the way you just started it from its how did it evolve from theory to the practice, and very nicely you discussed the core pillars, the principles, the fundamentals. I think that was a very nice orientation towards all those things till the 5.0, how we are going to evolve with that, which is really nowadays a hot topic, that how can the human centric and the AI they can work together, and what the future lies for us. So that is very interesting one, and I can see that most of the question you address in your wonderful presentation, and slowly and gradually you are doing it. Like for example, this one, this was the question, how ethical concern arise for that one. You have already addressed it, so I thought that
Yes.
how can I just ask. Then the this question was also that how you can encourage the student towards the development, innovation, and all those things. Another very interesting question, which you already talked about, it was related to interdisciplinary. You just see, and you already talked about it, that how important
Yes.
is interdisciplinary research and all. The two questions very quickly I would ask, which is a bit need your illustration. Uh, uh, One is they want to know your opinion regarding that. How can teachers prepare students for most disruptive technologies in currently shaping electronics and computer science? So your tips and recommendation will be very valuable for them. Yes, please.
Yeah, definitely. Actually, electronics and computer science are very incorporated, because if I go for the hardware components, most of the students already aware regarding the digital electronics, like a basic fundamental concept of the diodes and transistor, and having the concept of the microprocessor. So these are the very fundamental things where the students who are actually doing in the computer sciences or computer science, so they having the basic idea. So the teacher should have something that is which I want to focus on this, that is the sensor and transducer. So if the teacher just giving some information or a 2 or 4 session, so giving the idea about the what is a sensor, what is a transducer, and how they can react, because there are lots of transducer, lots of sensor. What is the difference between sensor, what is actually transducer, and how they can incorporate it. So if this thing is actually incorporated in the students, having some knowledge about the student, so they can, that the computer science student can easily design the any IoT devices, because they having the knowledge of the artificial intelligence, just needing some information of the IoT, Internet of Things, because and design Internet of Things, they already having the knowledge how to run the program in a Raspberry Pi or the Arduino. Okay, so if they having the little bit knowledge about the sensor, so they can easily implement the hardware module of the IoT. Now, if the IoT is designed, then the data is sent to the cloud, and in a cloud, they already having the data. They can now apply it for the any model by using the artificial intelligence. So this thing is a part of the students who are actually doing their graduation in a computer science. But if you go for the electronics, what will happen? In electronic students, the teacher should learn something, that is learn some classes on the artificial intelligence. That is how this model. And now in nowadays, what will happen if a students, they have no knowledge about the coding. Some student having some deficiency, or they don't want to they are actually always defer to run the code like that. They are not in little bit, they are not interested. So there are lots of simulation tool are actually used, like the Orange is one of the software through where the student can implement, or the researcher can easily implement some data put into the system, and they can get the result. And because in that software, in this platform, all the machine learning is available. You just put this data, and according to that, what kind of parameter you need, and what kind of that is the scoping output you need to analysis purpose, you can get this. So these are the main thing. There are two pole, and the teachers who are actually different domain, they can help the students how these electronic students can get some information from the computer science, and the students who are doing their graduation in a computer science, how they getting some information from the electronics domain. So they need to focus on this, so they can easily build their career, and they can switch anything anywhere.
Wow, very nice, wonderful. And I think you have answered the second question as well, because the second question they wanted to ask that in what ways can industry academia partnership enhance student readiness for future careers? So you are so wonderful that in one question you just answered the second question as well. Very nice, wonderful. So it was really pleasure to listen to your wonderful presentation and powerful content. I really thoroughly enjoyed this session with you. And at the end of the session, we ask our each guest that what are their message to the world. So, what is your message to the world as a speaker, author, teacher, researcher, trainer, learner, professional, and educator? Yes, please.
Thank you. First of all, I very much pleasure to here to give my session on the electronic imaging area of the electronics and computer science. As a researcher, as a faculty, as a teacher, I convey this information that the students who are actually students, or the research mainly focused on the students, please not align in a particular domain. You have to lots of things you have to learn. You have the capability to learn lots of things, because already I got some information, there's some question what I actually focused on. That is, if I electronic student, that not means that I only focus on the electronics, because it is an emerging area. Each and every day the technology is actually upgrading. So according to the electronics, you have to learn all the things, like you have to learn the electrical, you have to learn the computer science. So not only fixed in your domain particular area, you have to learn lots of things. That is a multidisciplinary is one of the thing where you have to learn the lots of domain, so that in future you can implement the things, and you can explore your thinking power. Number two, try to focus on some industry based training. That is, I already got the question regarding this. That is, if you implement some projects which are actually really needs, or this kind of implementation is already going on in a particular MNC company, so this kind of things should be learned by the any industry, or the any training institute, so that you can showcase your platform, or your research work, or your technical skill, to upgrade your technical skill. Number three, another, I already mentioned that whatever the, because when the students are go for the higher study, or for the any research work, or for any MNC company entering into this, they are always asking for that, after the completion of your graduation, what is your actual output. So do something that you can reflect in, that can be reflect in your CV, in your resume, that yes, after completing my graduation, I do this research work, or I learned this thing which is aligned to some sustainable development goal. That is, it satisfies some SDG, because as a human being, we have the huge responsibility for our society. It's not like that I just learn lots of things, but I do nothing for the society. Please do. It is actually, I can say that it is a spoil of time, because we are actually social we are social, so we have a responsibility to do something for the society. So whatever you do, each and everything that should be aligned to satisfy any sustainable development goal. So that is the 3 point I want to mention to the students to do and follow the steps, so that not you, the whole world can get the benefits from your study, from your work, from your research. Thank you.
Wow, wonderful message you have given to the world. I think these are very important for the particularly students to learn and adapt in their lives, because that will not only enhance their career and their career progression, but also will help to contribute back to the society. As you very nicely mentioned, that this is our responsibility to follow and even to link all of our work to the SDGs, to translate whatever we are doing for the betterment of the society and for the betterment of the globe, because we have the global citizenship. So that's very nice, wonderful. And thank you once again, Dr. Pijush Dutta, for your wonderful presentation. I really appreciate the way you just presented everything with the smiling face, and I could see your energy level from first minute to last minute. It was same. You are a wonderful teacher, wonderful contributor. I really enjoyed this session with you. And to the audience, please do follow our distinguished guest speaker through his research work, and you can email him for future learning and guidance. He's very generous and always ready to help the people. That's all we have time for today. Thank you once again, Dr. Pijush Dutta, for your wonderful presentation. Yeah,
Thank
thank
you.
you. Thank you. And I would like to thank our audience who joined us. If you have any additional questions about information shared today, please email us or connect to the speaker directly through his email, or maybe on social media you can contact him. We will just put his profile link on the description of this video. Thank you all for your support and liking our session. Stay tuned as many sessions are on the way. Please do not miss any session. Until next session, take care of yourself. Bye bye.